Hello students, in this video we'll introduce Ricatti ordinary differential equations. A Ricatti differential equation has the form y prime is equal to a0 of x plus a1 of xy. Those would be linear equations right here. And then I add on an a2x y squared. So those are called Ricatti equations. Okay? Now Ricatti equations are intimately related with second order differential equations that are linear. So what I'm going to do is I'm going to make a change of variable, and that change of variable will show me one way of doing this. So if I let y be negative w prime over this function a2 times w, I changed the dependent variable y by the following coordinate transformation. Let's check what y prime is going to be. So y prime is going to be the bottom times the derivative of the top. That's going to be a2w times negative w double prime. That's the derivative of the top. Minus the top, so that's going to be a plus w prime times the derivative of the bottom. So that's going to be an a2 prime w plus a2 w prime, all divided by a2 squared times w squared. That's what y prime is going to be. So let's still listen to the equation and see what happens over here. So let's look at these first terms over here. So the first term I see in my y prime is really a what? The first term I see in y prime is the a in the numerator will cancel, and it's going to give me a, and one of the w's will cancel. So I'm going to have a negative w double prime on top over a2 squared times w squared. That's the first term I'm going to get for the y prime. And then the second term I'm going to get over here is, let's look at this next term. I'm going to have an a2 prime, so I have a w prime, a w, and a w squared. So I'm going to have a plus a2 prime. One of the w's will cancel. I'll have a w prime divided by a2 squared, and then a single w. Got him over there. And the w squared over here is going to be just a single w. There's only one w since the w canceled out over there. Then over here, what do we have? The last term over here is going to be a plus what? Plus a2 w prime quantity squared. And then that's going to be over an a2 squared. So one of the a2 is going to cancel out. So this is going to be over w squared and then a2 squared. So one of those a2s will cancel out. And this is equal to what? This is equal to a0. That's good. Plus a1 times y. And what is y? It's negative w prime over a2w, and then plus an a2, and then I'm going to have a w square, y squared, which is going to be a w prime quantity squared, all divided by a2 squared, w squared. All right. So now let's look over here. So look at this term over here, right there, and then this term over here. Those terms are exactly the same, so those terms are going to cancel out. So this term over here is going to cancel with this term over here. And then we're going to be left with one equation over here. We're going to be left with a, let's simplify it a little bit, negative w prime prime over a2 squared w. And then a plus a2 prime w prime over a2 squared w is equal to a0. And then an a1 plus a1 with a negative sign w prime over a2 w2. And so now what we can do is we can multiply both sides of the equation by a2 squared w. And what will we get if we do that? So if we do that, we're going to have the right-hand side of the equation is going to turn into a negative w double prime plus a2 prime w prime is equal to, well, this would be a0 a2 squared w, a0 a2 squared w. And the second term over here, the a2, one of the a2s will cancel, one of the w's will cancel, and then I will have what left over? I'll have an a2 in the denominator, I will have an a2 in the numerator, and this term over here is going to become what? It's going to become negative a1 w prime, that's what the numerator is, and then the a2 w will cancel, I'll be left with just a single a2 factor, a2. And so if we rewrite this equation, what are we going to see? We rewrite this equation exactly becomes what? It becomes w prime, by putting it on the other side of the equation. And then what's the coefficient of w? So that I'm going to have a negative an a2 prime of w prime. I'm going to throw it over there. And I also have a what? A negative a1, a2 That's also w prime. And then plus a0 a2 squared w is equal to 0. And this is a what? This is a second order linear differential equation. So with this equation over here is second order. So we've turned this Ricatti equation into a what? Into second order linear with this transformation. So this transformation takes my Ricatti equation, turns into a second order differential equation of this type over here. And since I pulled a negative sign out over here, let's see, I have a negative sign mistake, so I put that over there, the negative a2, and that's negative, so that's going to be a plus since I pulled the negative sign out of everything, so that turns into a plus. So that's the exact form of this Ricatti equation, turning into a second order differential equation. Then the vice versa, if I start with this, if we start with the second order differential equation, conversely, if we start with y double prime plus p of x, y prime plus q of x, y equals 0, what we can do is we can set y to be the exponential of negative integral of u dx for some function u. And then what will y prime be? Well, y prime is just going to be negative u times y, so negative u times y, right? And then if I do y double prime, what does it become? Y double prime is going to become what? It's going to become negative u times y prime, and then minus u prime times y. But again, what is y prime? So y double prime now is going to be negative u squared, because, and that turns into a positive u squared, right? Because they have a negative u and then times another negative u, because that's what y prime is. And that will give me a what? That'll give me a y squared. And then minus u prime y is, that will be what y double prime is. And now, of course, what can we do? So now we can fill in this equation over here. So my y double prime, so what will our equation become? It's going to become u squared y squared minus u prime y. That's what y double prime is. This is going to be equal to negative p of x times y prime, but y prime is really negative u times y. And then plus q times y. And what we have over here is as a function of u, so the u equation over here, what does it look like? Well, I have a u prime, I have a u and a u squared, and everything else is just a function of y, so this exactly is a what? This is a Ricatti equation. So I can transform what? I can transform second order linear differential equations into Ricatti equations by means of this transformation, and I can transform Ricatti equations into second order linear by using this logarithmic transformation of change of the dependent variable. So Ricatti equations and second order linear differential equations are intimately related. If you can solve one of them, you can use these transformations to transform into the other type and solve the other type correspondingly. Thank you very much.